Greetings, this is Rob, Chief Flight Instructor for VATSTAR.com, and after this lesson, hopefully you won't say, "What a drag." Now, to keep the video at a reasonable length, I'm going to go through it kind of quickly, so pause and rewind as you need to, and if you still have questions, my contact information will appear at the very end. Let's start with a few vocabulary words. Altitude, well, that's how high you are. Of course, if you're in Denver, you're higher than most of the rest of us, but that's another story entirely. There's more detail to altitude that we'll get into later, but for now, height above the Earth is good enough for starters. When you climb, you gain altitude, you go higher. Losing altitude, flying lower, heading back toward the Earth, that's all referred to as descending. Level flight is what you're doing when you're maintaining a constant altitude. You're neither climbing nor descending. Accelerate, well, that means to go faster, in this case to gain airspeed. And landing gear, well, those are the plane's wheels. Now, the main topic of this lesson is the four main forces of flight. When we talk about making an airplane fly, there are four main forces we need to be aware of, and they each act upon the plane in a different direction. In the previous lesson, we covered lift. That's the upward force a wing generates as it moves forward through a stream of air. We also talked about thrust, which is the pushing power that the plane's engine generates. That's two out of the four main forces of flight. Lift pulls the plane upward, and thrust pushes it forward. So now let's talk about their opposites. First, the opposite of lift, which is weight. That pulls the plane down towards the ground, just like it does apples, pianos, anvils, your cell phone, whatever. Now, you can also call that gravity, but we tend to call it weight because that allows us to quantify it, to put it in terms of a number. And we're going to talk about that more in the next lesson. But lift and weight counteract each other, and that's very important to keep in mind. The heavier your plane is, the more lift it needs to take flight. When you have more lift than weight, the plane climbs, it goes higher. When you have less lift, the weight causes the plane to descend, to fly lower. We talked also in the last lesson about how to manage and regulate the amount of lift your wings produce, and that at a certain point, tilting the wings up higher will only work until the point where the airflow stalls, the amount of lift drops off, and your airplane essentially turns into an oddly shaped brick. We talked briefly about thrust in the last lesson too. That's the pushing power that your airplane's engine is producing. That could be in the form of a propeller pushing air backward like a fan, or a jet engine which compresses the air, lights it on fire, and blasts it out a hole in the back. Or it could be a turboprop, which is kind of like both. I'm not kidding. I've always found it kind of odd, but whatever. So regardless of the mechanism, thrust pushes the plane forward. Now, counteracting that is drag. You can think of that as like wind resistance, turbulent airflow over non-smooth surfaces. We mentioned last lesson about how a stalled wing causes tons of turbulent airflow, but really any surface of an airplane causes some drag, although usually in small amounts. The big culprits for drag are the surfaces that stick out into the airflow, in particular the landing gear. And that's why in any faster aircraft, the landing gear are retractable. In smaller, slower planes, the benefit of retracting the gear is outweighed, literally, by the weight of the retracting mechanism. You add all that weight to retract them, you need more lift to get off the ground, which means you need more thrust, and, well, you get it. Anyway, where was I? Oh, yeah. If thrust is acting to speed the plane up, drag is trying to slow it down. When thrust exceeds drag, the plane accelerates. It speeds up. When thrust is reduced or drag is increased, the plane slows down. Now, people will say that drag is a force that pushes the plane backward, and that's correct from a force vector standpoint, because obviously if thrust is pushing the plane forward, drag is pushing it backward. However, when you slow down, you reduce airspeed, well, you're reducing the force of drag too. So, to actually literally push the plane backward, you'd need a shipload of drag, the whole ship ton of it. That would be like hurricane force winds probably. So from like a physicist standpoint, yes, that's the correct direction for that force vector. So you do sometimes hear it said that way, that it pushes the plane backwards. For practical purposes, though, it really just slows the plane down. However, that concept is important, so remember that. Alright, so let's quickly summarize the key points. Lift is the upward pushing force that lifts a plane into the air. It's generated by the wings. Weight is the gravitational force pulling the plane back down to Earth. Lift and weight counteract each other, and whether the plane climbs or descends depends on which you have more of. If they're equal, you're in level flight. Thrust is the force of the engine pushing the plane forward. Drag is the force of the wind resistance pushing the plane rearward. Thrust tends to speed the plane up, while drag tends to slow it down. If they're equal, you're maintaining a constant speed. Got it? Good. If you have any questions, shoot them over to me in an email to cfi@vatstar.com. We'll see you in the skies.